So, good morning, everyone. I am Atharva. Today, we will be going to solve a few questions based on matrices and then a little bit on integration problem. So, the first problem for matrices will be let A equals to A here 1, 3, 1, 0, 5, 3. And this is a 3 cross 3 matrix, by the way. So, the given condition is if A cube equals 4a squared minus a minus 21i, where I is the identity matrix. Now I here is the identity matrix. I'll just denote it by IN. So the question asks, what is 2a plus 3b? So I'll give a 10-second time to actually understand this question, and then I'll start solving. To solve this equation by actually bringing all the terms to one side. So what we get here is a cube minus 4a squared plus a plus 24i. Sorry, it's 21i equals 0. This is a Cayley-Hamilton equation for a matrix of degree 3. Each of the coefficients present before a cube, a squared, a, and n actually represent something in the main matrix that is given in the question. What it actually represents is a cube minus trace of a. Trace means nothing but the sum of the diagonal elements of a matrix into a square plus sum of diagonal elements sum of minors of diagonal elements. So I'll just write the sum of minors of trace A minus ordinals of A into I equal to 0. The what I mean by modulus is actually the magnitude of the matrix. So let me first introduce what is actually the magnitude of a matrix. Let us take this example, for instance, and let us find the magnitude of it. So the magnitude of it will be few times, that's the first number, And then you just cover out this part of it, like the perpendicular part to the number which you've selected, and then multiply the diagonal elements minus the diagonal of this elements. What we will get is 2 times 3b minus 5. So 2 times 3b minus 5. And as you go, this is I, this is j, this is k. So we denote this as positive, negative, positive. Right? So minus a times b minus 0, that's nothing but b, plus 0 times anything is going to be 0, and the magnitude of this is given as 21. So 16 minus 10 minus ab is 21. So this is one equation we have from the given Cayley Hamilton representation. Let us denote it by 1. And now from the given equation, you can find that trace of a is actually 4, right? Minus 4a squared minus trace a into a squared. So minus 4 is equivalent of trace minus trace. Trace of a is actually equal to 4. Okay? And what's the trace? Trace is the sum of diagonal elements, right? So it's 2 plus 3 plus b. Now you might ask, why not this diagonal? This diagonal also kind of makes sense, but the thing we want to find is the value of b. Thus, the question asked is 2a plus 3b. So, given that we use this diagonal, you can easily figure out the value of b and plug it in this equation, and then find the value of a and use it to find the required condition. What we get is 4 equals 5 plus b. 5 plus b. And this gives us b is negative 1. Now that we've gotten b is negative 1, let us substitute in the first equation. Minus 6 minus 10 negative 1 plus a is 21. That gives it a is 21 plus 16. That's 37. So that a is 37 and b is negative 1. We get 37 times 2, 74 minus 3b. So 4 minus 3 is 71. That gives us the answer 71 as the final answer. I hope you understand this equation. This is quite a good equation. There is a similar model for a degree of 2, where I gets replaced here, b gets replaced here, and a squared gets replaced here. And yeah, that's about it. Thank you.